Okay, ayan, naka-record na. Kung babalikan natin yung statics nyo, okay, pag nagsosolve tayo, kung papansinin nyo, kadalasan ng given sa support, tatlo lang yung unknowns, no? Isang hinge at saka isang roller. So, dalawa and then pangatlo, which is the roller. Palagi lang 3 unknowns, okay? The reason for that is because yung available equations natin is meron ka lang tatlo. Summation forces horizontal, summation forces vertical, and then summation forces of the moment, okay? So, it means, kung babalikan natin algebra, para makapag-solve ka ng 3 unknowns, kailangan mo ng tatlong equations. So, sa statics, yun yun. Yung tatlong equations mo na yun, no? Forces x, forces y, and forces moment. Unfortunately, in real-life situations, okay, in engineering, hindi palaging tatlo lang yung unknowns mo, no? So, there are infinite number of unknowns, okay? So, kapag sumosobra ka na sa tatlo, okay, ang tawag natin doon is statically indeterminate. Okay? So, it means lahat ng sa statics nyo na discuss noon, those are statically determinate. Okay? So, pagdating sa deformable bodies, i-incorporate na natin yung pang-apat na equations. Naituro ko na yon last time, yun yung PL over AE or yung strain, yung deformation natin, ano? Iyon yung isa sa pinakamahalagang development sa materials engineering para makapag-solve tayo ng numerous number of unknowns. Okay. Even in your I guess sa materials nyo, I don't know, kung meron kayong finite element, kung naririnig nyo na yon, para ma-solve yung finite element analysis, itong PL over AE, this is one of the most used na wait. Dala ko nawalan ako ng internet. Yan yung isa sa pinakagamit na equation. Okay? So, gagamitin natin yon sa pag-solve ng iba't ibang questions. Okay? So, to give you an example, may inire-record ako, pero as of now, I will give another example for this one. Okay? Problem? Figure shows, anyway, ito ay nasa libro yata yung in-upload ko. And kaya-kaya nyo naman i-search yun eh. Okay, figure shows a copper rod that is placed in an aluminum tube. Okay? So, kumbaga in 3-dimensional, kasi minsan inaano ng bata, sir, hindi ko magets yung figure. Paano ba yan? I-exage ko. Yung pinaka-bearing plate natin, itong copper natin, parang ganito yung itsura niya, no? So, yan. Nakaganon siya. Hopefully, maidrawing ko ng ayos. Yan. Ganyan siya. Okay? And then, yung pinaka-aluminum natin, parang nakapaikot siya ng pagganon dun sa pinaka-copper natin. Okay? Ayan. Tapos, yun naman yung kanyang pinapaikutan ng pagganon. Okay? Ayan. Hidden lines. Ayan, parang ganyan, no? Zooming. Okay? So, kinat yun yung section sa gitna. Kinat yung section. Tapos, ito yung kinalabas ang figure. Okay? Ngayon, merong bearing plate. Okay? Sir, para sa yung bearing plate? Yung bearing plate, para kapag nagkaroon ka ng force, ang mangyari, tatamaan din yung aluminum. Okay? So, there comes a time na because sobrang bigat nung pin natin, bababa itong bearing plate natin. Okay? Ngayon, unang may stress si copper mo. Kasi, on the beginning, hindi naman nakatungtong yung pinaka-bearing plate natin kay aluminum. So, basically, hindi pa, kaburahin ko muna ito. Hindi pa may stress yung ating aluminum. Okay? In that way, there is a certain force na kung saan itong bearing plate natin, didikit pa lang dun sa aluminum. Okay? That is a certain force. Ngayon, kapag nilakihan mo pa yung P value natin, pati si aluminum, kasabay na niyang may stress. Okay? Kaya lang on that time, okay, ang mangyayari dyan, okay, pag nag-cut ako dito ng section, let's say, bumaba ito, no? So, pababain ko, exaggerated Say dyan, ito na yung pinaka-bearing plate natin because sobrang laki ng P. Okay? Mula dito, hanggang doon, ito yung magiging pinaka-deformation ng ating copper. Okay? I will have it delta C. Okay? Mula naman dito, hanggang dito, ito naman yung deformation ng aking aluminum. Okay? And then, itong natitirang maliit, that is around 0.005 inches. Okay? Ngayon, una, pwede natin gamitan ng sabihin natin statics, no? So, meron kang pababa, if you are going to have it summation forces, okay, summation tayo ng forces vertical equal to 0. Dalawa yung force na makikreate, no? Isang force galing sa aluminum and then isang force galing sa copper. Silang dalawa yung magtutulong para isupport yung P value natin. So, it means force sa aluminum plus force dun sa copper should be equal to the total force P. Okay? So, iyan lang yung dalawa. Isang equation. Ngayon, hindi natin magagamit yung summation forces horizontal kasi wala naman tayong horizontal na force. Hindi rin natin magagamit yung moment kasi they are concentrically. Ibig sabihin, tumatama at a common point. No? So, wala tayong makukuha. So, for this one, ito lang yung alam natin. PA plus PC equals to P. Okay? And then, meron tayong available. No? Ito yung ating available na mga E and then allowable. Okay? So, with this kind of problem, check natin yung ating deformation. Dito tayo kukuha ng isa pang equation. Okay? So, gamit to, yung itong figure na to, what we could conclude is that kapag nag-add ako, so let's say we can have it aluminum, okay, deformation ng aluminum plus 0.005 is equals to deformation of the copper. Tama? Okay. So, ito yung atin, deformation of the aluminum plus 0.005 inches is actually deformation ng copper. Okay, next. This one, pwede kong sabihin that would become PA, LA, all over AE of the aluminum. Ano? So, plus 0.005 is equals to PC, LC, all over AE of the copper. Okay, following? However, this term, di kasama yun, is actually P all over A. Okay? So, pwede kong sabihin that this is just actually the stress at the aluminum, LA, all over modulus of elasticity, A, plus 0.005 is equals to delta C, sigma C, LC, all over E sub C. Okay? So, we have now this working equation. Okay? Ilagay natin. Okay. Now, for the aluminum, ang kanyang L, okay, 10 inches lang. Okay, so we can have it as 10 inches. And then yung E ng aluminum, napin natin. So, ito siya. So, E. PSI naman siya. So, inches naman tayo. So, okay na yan. 10 times 10 to the 6. Plus 0.005 is equals to sigma C. And then, ang LC natin, yung original length niya is 10 inches. Kaya lang, kasama yung 0.005. Ano? So, we can have it as 10.005. Okay? All over E. So, ang E natin, we will be having here as 10. At 17, eto pala, sorry. 17 times 10 to the 6. 17 times 10 to the 6. Okay? And then, meron tayong allowable, ano? So, sabi nga natin, if you have two allowable stresses, i-check natin kung sino yung unang masisira. Okay? Dapat in both, in both equations, dapat si aluminum hindi lumagpas ng 10 KSI, tapos si copper hindi lumagpas ng 20 KSI. Okay? And take note, ano? Ito is naka-PSI, ito is naka-KSI. Okay? So, ang gagawin ko, assume. Okay, let's try, no? Kung sino ang unang, sa tingin nyo, sino una? Si aluminum kaya o si copper? Okay. So, sige. Let's try it this way. Okay? Unahin ko, I will try, hindi natin alam, assume copper fails first. Hindi natin alam eh. Okay? So, si copper, papalitan ko. So, I will have it 10 all over 10 times 10 to the 6 plus 0.005 is equals to, yung copper ko, I will now have 20. But this time, I will make it 1,000. Ano? So, 20,000. And that is in PSI. Multiplied by 10.005 all over 17 times 10 to the 6. So, may makukuha akong aluminum. So, dapat yung makuha kong stress ng aluminum hindi lalagpas ng 10. Kasi kapag lumagpas, it means mali yung assumption ko. So, we have it as sigma A, 10 times 10 to the 6 plus 0.005 equal to 20 times 10 to the 3 times 10.005 all over 17 times 10 to the 6. All right. Okay. So that is around 6,770.59 PSI. Okay? So since, okay, sigma A is less than 10 KSI, ang ating conclusion, right yung ating assumption. Okay? Kapag lumagpas, babalik tayo dito. Okay, babalik kayo doon. Kaya lang, i-assume naman natin si aluminum naman yung masisira. So, ito naman yung papalitan natin, then ito naman yung magiging unknown. So, dapat yon any of the two, hindi lalagpas. So, what does it mean? So, yung ating copper ay mayroong 20,000 PSI na stress. And then yung ating aluminum is meron lang 6,770.59 PSI. Okay? So, it means to get for the P sub C, and that would become equal to sigma sub C multiplied by E sub C. So, 20,000 multiplied by area ng copper, which is 2 inches. So, you have here 40,000 pounds. Okay? Same thing, we can have it aluminum. Okay? So that would become 6,770.59 and then multiplied it by 3. So you will have it aluminum equals to 20,311.77 pounds. Okay? So babalik ako dito. So that the value of P would become equal to 20,311.77 plus 40,000. So that's around 60,311.77 pounds. Okay? So this is now the maximum, okay, value of T na pwedeng isupport ng ating system. Question. Okay, so I will give you time to copy. Sige, copy kayo. Na aluminum yung mag-fail lang muna. So, gagamitin, instead na ito yung papalitan ko, yung 20, ito ang gagamitin ko. So, you'll have it as 10,000 all over 10 times 10 to the 6 plus 0.005 is equals to, ito naman yung nawawala. Okay? So, times 10.005 all over 17 times 10 to the 6. Okay? So, may makuha ako ngayong sigma C. Dapat yung sigma C ko, hindi ako lalagpas ng 20. Kasi kapag lumagpas yon, ibig sabihin, mali yung assumptions natin. Okay? So, check natin kung ano mga lalabas. 10 times 10 to the 6 plus 0.005, 10.005 all over 17 times 10 to the 6. Okay, so ang lumabas is around 25,487.26. So obviously, lumagpas siya dun sa kanyang allowable stress. So it means mali ito. So kapag napatunayan mo mali siya, babalik ka dito. Okay? So it means kahit ano yung i-assume mong una, makikita mo naman kung tama or mali yung assumption mo. Okay? Question pa po. I'll give you 5 minutes to copy. 12:21. Proceed tayo. Question pa po? Okay? So, delete ko na. Ay, nababasa ba o maliit? Ayan. Okay. So, let's have it another example. Then, ayan, na-post ko na pala sa ano yung videos, no? So, marami pang example doon. So, all you have to do is to study on that. Okay? Tomorrow, sa ibang section, yung sabihin, dalawa lang naman kayang hawak ko. We will proceed with another topic, and that is thermal stress. Okay. So, i-record ko rin yon, tapos isi-send ko rin sa inyo, no? So, para mapag-aralan nyo. And then, maybe by next week, we will be having the next quiz. Ang topic is all about the yung statically indeterminate and thermal stress. Okay, yun lang yung coverage. So, kaunti lang. And that would run from your first hour hanggang second hour, 2 hours. And then yung third hour, we will proceed with the another topic, which is the torsion. Okay? So, malapit na kasi yung ano nyo, yung finals nyo. Nandun ka, almost kalahati pa lang tayo nung before modules. Okay? Oh, ang hirap eh. Naghahabol tayo pinaigsi kasi. Meron naman daw kayo kasing IL. So, expect nila nag-aaral kayong mag-isa dun sa IL. But I doubt. Okay. So, next. Figure shows a rigid bar that is supported by a pin at A and 2 rods. One made of steel and the other made of bronze. Neglecting the weight of the bar, compute the stress in each rod caused by the 50 kilonewton using the following data. Okay. Sir, parang kamukha lang yun na nakaraan Oo. Kaya lang, yung nakaraan, they are almost of the same material. Okay? So, ito, iba-kaiba ng material. Ibig sabihin, hindi given kung ano yung pagbaba. So, ano ba tinatanong? Stress. Pinapakompute yung stress. So, basically, una, statics muna tayo. Ang ginagawa natin dati sa statics, yung free body diagram. Okay, so ito yung rod. Okay. And then, meron tayong force dito. So, that's around ilan? 50 kilonewton. Okay. And then, dito, meron akong force ng bronze. Tawagin natin yung PBR kasi bronze. And then, dito, may force din tayo ng steel. So, we can have this P and then we can have it as steel. O, B na lang to para madaling isulat. Okay, B na lang. So, we can have it as steel. Okay? Here, since this is a pin, so meron tayong vertical reaction and then meron tayong horizontal reaction. All right? And then let's have it the distances. Okay. So yung distances natin based on the figure, this is 0.6 meters. This is 1.0 meter. And then 0.8 meters. Okay? So, since we are after for the forces on the steel and then the bronze, pwede tayong mag-summation moment at point A. Kasi pag na-summation tayo ng moment at point A, wala nang moment yung aking horizontal and then yung aking vertical reaction. Okay, so I will have it summation moment at A equal to 0 to be equilibrium, and then we will be having here clockwise to be positive. So we will have it as 50 multiplied it by, ayan, 1.6 plus 0.8, ilan? 2.4. So you have it 2.4. And then minus P sub S, multiplied it by 0.6. And then minus P sub B, multiplied it by 1.6 equal to 0. Okay? So, first equation natin, ililipat ko sa kabila, 0.6 of steel plus 1.6 of bronze is equals to 50 times 2.4. Okay, so you have your 120. Okay? Now, hanggang doon lang tayo sa statics. Okay, wala na tayong ibang mapagkukunan. So, hindi natin kaya ngayong isolve. Kasi nga, okay, ito sinasabi ko, tingnan niyo yung supports. 1, 2, 3, 4. 4 yung naging supports, no? Unknown. So, this is statically indeterminate. Okay. However, because of the properties of the material ng steel and then the bronze, we would be able to get some clue. Okay, paano yun? So, i-assume natin, nasa ng aking ruler. Okay. We will assume na itong pinaka, i-exage ko ulit, okay, yung pinaka rod natin ay nag-deflect in this way. Okay. Assuming. Mula dito hanggang doon, ito yung aking deformation ng steel. And then mula dito hanggang doon, ito yung aking deformation ng bronze. Okay? Now para siyang, lakihan ko. Para siyang isang malaking triangle at saka isang maliit na triangle. Okay, assuming on that. Okay? Ngayon, yung malaking triangle ako, okay? Yan yung malaking triangle. So, I will have it deformation ng bronze. So, that's around deformation, okay. Deformation of bronze. Dito ko na lang nalagay. Okay. All over. Okay, lagyan ko. Over yung pinaka-adjacent niya. So, that's around 1.0. 1.0 ba yun? Yeah, 1.0 plus 0.6. So, that's around 1.6. Okay? Similar triangle dito sa maliit. So, we can have this deformation of steel all over 0.6. Okay? So, ito yung isa nating equation. Okay? Now, to get for this one, okay, ilagay natin that is equals to 1 over 1.6. Okay? P, L all over AE. And we are speaking of the bronze. And 1 all over 0.6. PL all over AE of our steel. Okay? So, again, kagaya kanina, we could have it as this term as our stresses. So, P all over A. So, that is around 1.6. 1 all over 1.6. Sigma of bronze. Lagay ko na yung length ng bronze. So, gawin nating 2,000. Gawin nating mm. So, 2,000 para maging mm. All over the E. So, yung E is gigapascal. So, para maging megapascal siya, ita-times natin by 1,000. Ano? So, bronze. So, that is around 83,000 para maging megapascal. Okay? So, equal to 1 all over 0.6. So, we will be having here as sigma para sa steel. And then, yung length niya is 1,000 lang. All over, we will be having here 200,000. Okay? So, ito pwede mo paikliin. So, iyan na natin. 2,000 divided by 1.6 times 83,000. So, that's around, ilan to? 0.015, ay, maliit, gawin kong 5 decimal na. 0.01506 of sigma B is equal to 1 all over 0.6, 1,000 divided by 200,000. So, that's around 1 over 120 or 0.00833 of sigma S. Okay? So, ayan, meron kang dalawa. Okay, remember that this one, okay, pwede ko naman to kasing gawin na yung P sub S ko. So, that would become 0.6 sigma S and then multiply ako ng area. Okay. So, I have here the area. of the steel, which is 600. Okay. So, take note of this one. Ang lalabas dito, kapag ito ang ginamit mo is in Newton, ano? Dito rin Newton, kaya lang ito naka kilonewton. So, ito pwede nyo i-convert into Newton. Okay? So, 1.600 plus 1.6 sigma ng bronze, multiplied it, ano yung bronze? 300 mm. So, equals to 120 para maging Newton siya, no? Kasi, uulitin ko, itong sigma ko, so in megapascal, pag minultiply ko ng 600, lalabas sa kanya is Newton. So, you have to be consistent. Baka mamali kayo. Okay? So, ngayon, I will have it as sigma B is equals to, ito, i-divide ko both side, no, by 0.01506. So, you have it 0.01506. Okay? So, divided by 0.01506. So, you will be having 0.55334 of S. Okay? So, papalitan ko. So, you will be having here, okay, on this part, 0.6 sigma S multiplied by 600 plus 1.6. This time, yung sigma B, papalitan ko ng 0.55334 of sigma S. Okay? Ayon yung para dito, no? And then multiplied by 300 is equals to 120,000. With this, I can now solve for the value of sigma S. Okay? So that's 0.6, 600 plus 1.6, 0.55334 of X multiplied it by 300 is equal to 120,000. Okay. So you will be having here 191.81 megapascal. Okay. And then solving for this one, substitute. So that's around 0.55334 of 191.81. So you have now on the bronze. So 191 times 0.55334. So you will be having here 106.14 megapascal. So, ayun na, na-compute na natin yung stresses dun sa dalawa. Okay? Question on that? Okay, so ganun lang, no? So, you will be having here two equations. So, malilito lang siguro kayo sa mga conversion kasi iba naka-gigapascal, naka-mm squared, so, naka-megapascal. Okay, that's how you do statically indeterminate using the formula of the deformation. Question? Okay. Copy po.